Hello everybody, I can prove parallel, isosceles, and bisect/midpoint by proving triangles are congruent. I'm always proving triangles are congruent, and then using CPCTC. So basically for every proof in this lesson, we're going to use CPCTC to get to something else. So we're always proving triangles are congruent. That's not changing, so this thing starts the exact same way. Statements, reasons. I'm going to go kind of quickly through the actual proving triangles piece because that's nothing new at this point. Ln bisects angle KLM given. This is an angle bisector. An angle bisector. Creates two congruent angles. L is being bisected. There are my two congruent angles. Angle MLN is congruent to angle KL. That's one pair of things. I move on to the next given. Angle LKM is congruent to angle LMK given. I'm out of givens. I go to my additional tools. Reflexive property for Ln is congruent to Ln. Reflexive property. Now that I have three things, I state that triangles are congruent. Triangle MLN is congruent to triangle KLN. Angle, side. So that's nothing new. You're always proving triangles are congruent. Now, ultimately, I want to prove that n is the midpoint of mk. So I need to kind of think backwards here. If n is going to be the midpoint of mk, then I need mn to be congruent to nk. Now that these triangles are congruent, now the blue triangle is congruent to the green triangle, do I know that mn is congruent to nk? Yes. I know that they're congruent because if those triangles are congruent, CPCTC states that any of the corresponding parts are congruent, including mn and nk. So now I can write mn is congruent to nk by CPCTC. And now that those two are congruent, that makes n the midpoint of mk. And the reason is the same that I would do in the regular direction. A midpoint creates two congruent segments. So this would apply to midpoint, line bisector, angle bisector. If you want to prove something that's usually a given, you kind of have to work backwards. In order for n to be the midpoint of mk, I need mn to be congruent to nk. And in order to get that, once the triangles are congruent, I can use CPCTC to get that. And once I have that, I can state that n is the midpoint. So there's kind of three pieces to this. That's one, that's proving midpoint or line bisector or angle bisector. Again, once the triangles are congruent, we use CPCTC to get what I need to get. I needed those to be congruent for n to be the midpoint. Number 3. I'm always proving the triangles are congruent, so I'm not going to even talk about anything else until we get that done. Statements. Reasons. Again, I'm going to go through the triangle part quickly. OF is the perpendicular bisector. Of WL given Perpendicular bisector creates congruent right angles from perpendicular and bisects. So I can state that angle WOF is congruent to angle LOF. I'm going to say perpendicular lines. I don't have to say perpendicular bisector. Perpendicular lines form congruent right angles. And I can state that WO is congruent to OL, a line bisector. And you can say a perpendicular bisector. Either way, a line bisector creates two congruent segments. I have two things I'm out of givens, additional tools, reflexive property, OF is congruent to OF, reflexive property. Now that I have three things, I can state that triangle WOF is congruent to triangle LOF. I've got SAS. And now let's pause and take a breath and talk about what we're going to do next. It wants me to prove that triangle WFL is isosceles. Well, in order for a triangle to be isosceles, it either needs to have two congruent sides or two congruent angles. I mean, both those things are true, but if I can prove that it has two congruent sides, I'm good. If I can prove that it has two congruent angles, I'm good. So I'm looking at triangle WFL. I'm looking at the blue triangle. Right now, I do not have two sides of that triangle being congruent. I do not have two angles of that triangle being congruent. But now that the triangles inside are congruent, now that the green and the red are congruent, can I use CPCTC to get either two sides of the blue triangle or two angles of the blue triangle to be congruent? And the answer is yes. In fact, you have options here. You could say that WF is congruent to FL through CPCTC, or you can say that angle W is congruent to angle L through CPCTC. So let's just do WF is congruent to FL. Since those triangles are congruent, WF must be congruent to FL through CPCTC. And now that I have WF congruent to FL, triangle WFL would have to be isosceles because an isosceles triangle has two congruent sides. If you stated that the angles were congruent, if you said that angle W was congruent to WL with CPCTC, then you would say an isosceles triangle has two congruent angles. So that's how we prove isosceles. We prove the triangles are congruent. We're always proving the triangles are congruent. And once the triangles are congruent, I'm using CPCTC to either get two sides of the triangle congruent or two angles of the triangle congruent. It doesn't matter which. Sometimes you'll have a choice. Sometimes you won't. One more big thing to talk about, and this is actually very important for when we come back to proofs later in the course. Parallel. So again, let's just start by proving the triangles are congruent. There's nothing new there. If you still can't prove triangles are congruent, what are you doing? You should not be watching this video. You should be watching proving triangles are congruent or using CPCTC. All right, you cannot do this until you master the basics, and if you don't master the basics, then you're just not going to do this, and that's okay. I guess that's okay, I guess, depending on who you are. SE and AR bisect each other. Given a line bisector creates two congruent sides. Since they bisect each other, they're both being cut in half. So I have SB is congruent to BE, and I have RB is congruent to BA. I have two things congruent. I need 3. I'm out of givens. Additional tools, vertical angles. Angle SBA is congruent to angle RBE. Vertical angles are congruent. Now that I have 3 things congruent, I can state that triangle SAB is congruent to triangle ERB, and I've got SAS. So now we pause. The triangles are congruent. Let's pause. Let's talk about parallel. I know that if I have parallel lines cut by a transversal, I know that I can state that the alternate interior angles are congruent. I can state that the corresponding angles are congruent. I can state that the alternate exterior angles are congruent. If the lines are parallel, then those 3 things must be true. It works the opposite way as well. If I know that alternate interior angles are congruent, then the lines must be parallel. If I know that corresponding angles are congruent, then the lines must be parallel. If I know that alternate interior angles are congruent, then the lines must be parallel. So, to prove, and we came up with this earlier in the course, not with proofs, but to prove or show that lines are parallel, I need either congruent alternate interior angles, congruent alternate exterior angles, or congruent corresponding angles. And this concept right here is very, very important, because when we do the very commonly asked 6-point questions, they often utilize this concept. We're going to need to prove lines are parallel. To prove lines are parallel, I need either congruent alternate interior, congruent alternate exterior, or congruent corresponding angles. So, now that I have the triangles congruent, in order for these lines to be parallel, I need either congruent alternate interior, congruent alternate exterior, or congruent corresponding angles. As we spoke about, extend, extend, extend. So, I don't have anything right now, but if those triangles are congruent, I'm looking for alternate interior, alternate exterior, or corresponding angles that are inside those triangles. And I see them right there. So I can state that angle SAB is congruent to angle ERB because of CPCTC, because if those triangles are congruent, those corresponding parts must also be congruent. And now that I have alternate interior angles are congruent, if alternate interior angles are congruent, then the lines are parallel. So now I can state that SA is parallel to RE, and I would do the same reason that we did in the other direction. Parallel lines cut by a transversal create congruent alternate interior angles. So, very important, not just for this lesson, but for other lessons that will come up. If they want you to prove parallel, whether it says to prove parallel or whether we need that for something else, I need either alternate interior angles to be congruent, alternate exterior angles to be congruent, or corresponding angles to be congruent. So we had to use CPCTC once these triangles were congruent to get angle A and angle R. And once I had that, those are alternate interior angles. Those are congruent, then the lines are parallel. So everything in this lesson, there's really three things here. There's proving parallel, prove the triangles are congruent, use CPCTC to get congruent alternate interior, alternate exterior, or corresponding angles. There's proving isosceles to prove isosceles, prove the triangles are congruent, use CPCTC to prove either corresponding sides or corresponding angles are congruent that make the triangle isosceles. And if I want to prove a midpoint or a line bisector or an angle bisector, kind of work backwards. If n is the midpoint of mk, then mn is congruent to nk. So prove the triangles are congruent. Use CPCTC to state that those segments are congruent. And if those segments are congruent, then n would have to be the midpoint. This is not a simple lesson. It's not at all. You have to know how to do the basics of proofs. Once you know the basics of proofs, this is really now understanding what CPCTC actually is and how to utilize it. But it is what it is. Practice. See ya.